Hello everyone, you're welcome to Zishan classes. Today we're going to look into another question from the chapter Kinematics. We're looking into pulley mass systems, and the question here is, what is the minimum acceleration of the block A so that the blocks 1 and 2 remain stationary with respect to A? The concept is, if we push the block A very hard towards the right, this block 1 is going to move backwards and block 2 is going to move upwards. But we have to calculate the minimum acceleration. We are talking about A being pushed with minimum acceleration. In that way, we should understand that the one block has the tendency of moving ahead instead of moving back when A was pushed very hard. Now, keeping this in mind, we will draw the free body diagram of the block 1. So these are the forces acting on the block 1. Like we discussed, the friction acting on the block 1 is acting towards the left because 1 has the tendency to move ahead. Also, you may notice that I have not written the value of friction equal to mu r. The reason being, if the block 1 is stationary with the block A, with respect to the block A, means that the friction has not reached its limiting value. The limiting value of friction is mu r. It has not reached. It is lesser than the limiting value. Now we will write the equations for the motion of this block. This block is moving along with A, the acceleration of which we suppose is A. The acceleration we have to find. So this also has an acceleration equal to A. Writing the equations, it will look like T minus F1 equals m1a in this one, and r1 equals m1g. And we will also show the direction of acceleration A. Now we will talk about the second block and write the equations for it. This block has the tendency to move downwards. Friction is going to act upwards, F2. And that's it. These are the four forces acting on it. The equations for this body are going to look like, also will show the direction of acceleration. So it's moving with the block A. that way. There's no acceleration downwards or upwards. So small a this way. Equations are going to look like m2g is equal to t plus f2. We'll name this 3, and r2 is equal to m2a. The only force responsible for the motion of this body this direction in this direction is r2. So r2 will be equal to mass times acceleration of the block. So this is it as far as the equations are concerned. We are going to solve for A. First we'll subtract equation number 1 from equation number 3, which will give us t plus f2 minus t plus f1 equals m2g minus m1a, which will give us f1 plus f2 is equal to m2 times g minus a. Also, we know that m1 and m2 are same, so we will replace m2, m1 and everything with just m. So f1 plus m2, f1 plus f2 is equal to m times g minus a. Like I said before, the values of friction acting on these two bodies has not reached its limit because we are moving with a minimum acceleration. We'll use this concept to find the value of A. How are we going to do that? See, F1 plus F2 must be lesser than or equal to mu R1 plus mu R2. Mu R1 and mu R2 are the limiting values, are the limits of F1 and F2. But we already know what F1 plus F2 is equal to. M times G minus A. Also, we know what R1 and R2 are equal to. How? Equation number 2 and equation number 4. We have R1 equals to M1G, R2 equals to M2A. We'll put these values. Mu times Mg plus mu times Ma. I've replaced M1 and M2 with M. M from both sides cancels. We have G minus A is lesser than equal to mu G plus mu A. This can also be written as mu G plus mu A is greater than equal to G minus A. We'll bring A here and we'll take mu G to the right, which will give us A times 1 plus mu is greater than equal to G times 1 minus mu. This gives us A is greater than equal to G times 1 minus mu divided by 1 plus mu. So, if for all of these conditions to be satisfied, the value of acceleration must be larger than G into 1 minus mu divided by 1 plus mu. What is the minimum value of A acceptable here? The minimum value of A acceptable here is A minimum equal to 1 minus mu divided by 1 plus mu. That's it. That is the answer, the minimum acceleration. So, that's all there is to this question, just keep in mind that the frictions have not reached their limiting value, and that is the key to the problem, and rest everything is simply solving the equations. Also, the tendency of the block 1 to move to the right was one of the keys. That's it. I'll see you in another problem. The minimum acceleration is this. You have a good day.